So now that we've done a review for trig, we are going to be looking at vectors, but vectors moving in 2 dimensions. So I mean, if we have a vector going north and south, we're going to add it to a vector going east or west. What we've been doing is something like this. We have been looking at vectors going in the same type of direction, so north and south or east and west, not both. So let's go ahead and look at an example of that. So this is something that we have been doing and we're familiar with. So if I'm going to a theme park and I'm going to the new awesome ride. So let's say the new awesome ride is at the north end of the amusement park. Well, I'm going to walk, and I'm going to go at a pace of, he's looking kind of funny there. I'm going to go at a pace of 5 meters per second. That's actually pretty fast. So I am walking with that pace at 5 meters per second, and I see that they have the people mover. So it's basically like a conveyor belt for people. And then people get on it, and they should be walking with the conveyor belt. Sometimes they just sit there, though. So we have one conveyor belt, one people mover going to the north at 5 meters per second. And then I also have another conveyor belt, or people mover, going to the south at 5 meters per second. Well, I'm already moving north at 5 meters per second. So if I get onto this people mover, well, I will be going 5 meters per second, and then the conveyor belt will also be going 5 meters per second. So my resulting speed will be 10 meters per second because I can simply add them together since they're going in the same direction. Well, if I get on the other people mover going in the south direction, and I'm moving 5 meters per second north, well, I'm going 5 meters per second north, and then the people mover is going in the opposite direction at 5 meters per second north. My velocity will be 0, and, well, people will stare at you, but you know that your velocity will be 0 here because you've got a vector going north and a vector going south, and then they are the same number or magnitude, so you subtract them. So if you're going in the same direction, you add them together, and then if you were going in opposite directions, you subtract them. So this is what we have been doing, and we're used to doing this. But now we're going to add vectors that are going north, oops, that looks really bad, north and south, and then also east and west. So we're going to have something that looks a little bit different, and we have to use a different method. So let's look at that. Okay, so here we go. If we have arrows in this class, usually these are going to be referring to vectors. So these are separate vectors, and if I'm going to put them together to get a resultant vector, so anytime that I add vectors together, I get a resultant, what I'm going to do is I'm going to add them from tip to tail. So I can't put the tips of the arrows together, I can't put the tails of the arrows together. So I'm going to add them from tip to tail. So here's one vector, and then I'm going to put down the other vector. So this is the tip, so the tail of the other vector should be right here. It should look like this. So if I have 2 velocities going in these directions, what I actually have is a vector going like this. So when I connect them, this is my resultant vector. And I added them from tip to tail. And then I could also put them together in different ways. So let's say, look, there's one other way I could put them together. Let's say I started with this arrow instead, which is fine. I'm just going to make sure I put them tip to tail. So here's the tip of this arrow. When I put the other vector with it, I have to put the tail end on the tip, so it's going to look like this. So when I connect them, it'll look like this. But if you look at this line right here and this line right here, they are the same line. You're just looking at it from a different perspective. But the resultant vector is the same, even if you start with the other vector instead. And we're going to look at another example in just a minute. Alright, so after escaping from a maximum security stockade, the A team is trying to travel north across a 350-meter river in a speedboat. The boat can travel at a speed of 25 meters per second in still water, and the river flows to the east at 11 meters per second. What is the resulting velocity, and what is the angle of that velocity? Okay, so this is going to be a little bit different. We have two vectors. We have a speed of 25 meters per second, and then we also have a speed of 11. But one is going to the east, and then one is going north, because they're going across the river, and that's north. Alright, so let's go ahead and work this problem out. Let's draw a picture first. So we have our river right here, and we have a boat that's trying to cross the river, and the river is about 350 meters wide, and it's going north. The boat is going north with a speed of 25 meters per second. But the river is going to the east, like that, at 11 meters per second. So we have two velocities here. So we know the boat can't go straight across the river because the river is going to bring the boat to the east. So what we actually have is movement that looks like this. So this is our resulting velocity. This is our resultant vector. Alright, so the boat's actually going to move in a northeast direction instead of just north, because the river's going to pull it down to the east. And it is asking, what is the resulting velocity? So we want to know the resultant velocity here. Okay, and we also want to know the angle. So we want to know the direction the boat's going, and the more specific direction than just saying northeast. So what we really want is this angle right here, because the boat is moving, it's coming in from this direction. So this is the angle that the boat is moving at. So, well, I know that I have two sides of a triangle here. I cannot simply add these two numbers together and get 36 and say that's my velocity. It will not work that way. I can't subtract them either because they're not moving in opposite directions. They're moving in different types of directions. But what I do have here is a right triangle. So I can use either SOHCAHTOA or I can use Pythagorean Theorem here. Since I've got two sides, well, I want to use the easy way. I would like to use Pythagorean Theorem. I've got the A side, the B side, and I'm looking for the hypotenuse. So I'm going to use A squared plus B squared is equal to C squared. Because I've got two sides of the triangle, I can do this. So it doesn't matter which side is A or B, but C will always be the hypotenuse, which is always away from the right angle. So A is 25, so 25 squared. It could be 11. It doesn't matter which one you pick. 11 squared plus that is equal to C squared. So when I do this, I'm going to get 25 squared, which gives me 625. plus 11 times 11 gives me 121 is equal to c squared. So when I add those two together, I get 746 is equal to c squared. So at the end, what I'm going to do is I'm going to take the square root. So c is equal to 7.3 meters per second. So the boat is actually traveling with a speed of 27.3 meters per second at this angle. So let's go ahead and try to figure out the angle of the boat. Okay, so we're trying to figure out the angle. We've got three sides of this triangle. So we're going to be using SOHCAHTOA. I cannot simply add the angles up here and then subtract by 180 because I do not have the other angle right here. So I'm going to use SOHCAHTOA. And since I have all sides of the triangle, it really doesn't matter which one you pick. You should be able to use any of them. So let's look at SO. So sine is sine of theta is equal to opposite side divided by the hypotenuse side. So before I even do that, let's decide what the opposite and adjacent sides are. So we're looking at this angle. This side will always be the hypotenuse because the right angle is away from it. But this side, the 25 meters per second, is touching this angle, so that will be the adjacent side. And then this side is not touching the angle, so that will be the opposite side. All right, so sine of theta, theta is unknown, that's what we're looking for, the angle right here, is equal to the opposite side, which is 11 meters per second, divided by the hypotenuse, which is 27.3. So 11 divided by 27.3. So sine of theta is equal to 0.4029. 11 divided by this gives me that. All right, so now I just need to get rid of the sine. So remember, opposite of sine is not cosine. You're not dividing by sine. You need to take the arc sine or the inverse, which looks like this, of both sides. So that'll cancel out your sine. Theta is equal to this now. All right, so your angle here is going to be 23.7 degrees. So this angle right here is equal to 23.7 degrees. All right, so I want to talk about the fact that we just solved for a resulting velocity, and what we did is we looked at the x component and the y component. So basically what we did is we said that we had a velocity going up of 25 meters per second, and then we had a velocity going over with 11 meters per second, and then we found this velocity. Well, we know that the 25 and the 11 affected the resulting velocity. But what you need to keep in your head is that this velocity going up, so the y velocity because it's going up, and the x velocity because it's going over, do not affect each other. They only impact the resulting velocity. X does not affect y, and y does not affect x. So the statement right here that says when objects are moving at angles, the velocity in the x direction directly affects the velocity in the y direction. That is false. Okay, so let's go back to the problem that we were just on. So in this problem, it's the same scenario. So after escaping from maximum security stockade, the A team is trying to travel north across a 350-meter river in a speedboat. The boat can travel at a speed of 25 meters per second in still water, and the river flows to the east at 11 meters per second. So this one says, how long does it take to cross the river? How far down the river do they end up? All right, so let's look at this problem. So back to our little scenario here. Here's our river. They were going up with 25 meters per second. And then they were going over with 11 meters per second. And then in the last problem, we said that the resulting velocity is actually 27.3 meters per second. So that's the actual speed that we were moving at. So whenever you're looking at a problem like this, you have an x component and you have a y component. Because remember, y is always vertical. X is horizontal. This question is asking, how long does it take to cross the river, and how far down the river do they end up? So I would like to know the time it takes to cross the river, and I would also like to know how far down the river did we end up. So how far east did this person end up? So what we're looking for is a distance. So we're looking for a displacement, and we're looking for the displacement in the east direction. So whenever you have a problem like this, always divide the y components up with the x components. So put everything into a category. So let's go ahead and divide everything out. So in the y direction, we know that the velocity in the y direction, so I'm going to write Vy, is equal to 25 meters per second because it's going up. I know in the x direction, Vx is going to be equal to 11 because that's the velocity going to the east. I know that I'm looking for the displacement in the east direction. That's what it's asking for. And then I also am looking for the time it takes to cross the river. Okay, so in the problem, it also states that the river is 350 meters wide. So the river is 350 meters wide. That is my delta y. I'm going to say delta y. It's a distance or displacement just like this. But to go across the river, we need to go across 350 meters. So delta y is 350 meters. Delta x is unknown. We're looking for that. So right here, I see that I have a velocity, I see I have a displacement, I see I have a time. There is an equation from a long time ago that we talked about that has velocity, displacement, and time. This is the velocity equation. So my velocity equation says that velocity is equal to displacement divided by time. That has three variables. And right here, I'm looking in the y direction. I have velocity, I have displacement, and I'm looking for time. So I'm going to solve for time using these two variables. So let's go ahead and do that. So velocity is equal to 25 here. So I'm just plugging everything into this equation right here. Displacement is equal to 350 and divided by time. So I need to get time. In order to do that, though, I am going to multiply delta t by both sides. I don't like the fact that the variable is at the bottom, so I'm fixing that. So I have 25 times delta t is equal to 350. If I leave it on the bottom, it's difficult to see what I need to do. Do I need to divide? Do I need to multiply? How am I dividing if I divide? If I multiply delta t by both sides, I can easily see I need to divide both sides by 25 to get the answer. So right here, it's 350 divided by 25. 14 seconds. So my time to cross the river is equal to 14 seconds. All right, so I know that the time it takes to cross the river is 14 seconds. But the time is also going to be the same in the x direction. It is also 14 seconds. So by the time I get down to the end of the river, which is 350 meters, I will be further down the river also, and it will be 14 seconds. So the time will be the same on both sides. So time is going to be the same on the x side and the y side. The distance will not be the same, the velocity will not be the same, but the time will be the same. So now I have time on this side, I have x on this, or velocity, I'm looking for displacement, I can solve. So let's go ahead and plug it in. Velocity is equal to 11 divided by, or is equal to delta x, which is unknown, divided by time. So let's multiply 14 by both sides. So delta x is equal to 154 meters. So the team crosses the river at 350 meters wide, so they go up 350 meters and then they go over 154 meters. And they're going to do that with a velocity of 27.3 meters per second. All right, so let's look at another problem that's similar to this. And I highly suggest you try it on your own and then pause the video. So pause, try it on your own, and then check it. Okay, so a man can swim 2 meters per second in still water. He attempts to swim north across a river that has a current of 3 meters per second east. How long does it take him to swim the 100-meter wide river? How far downstream is he pushed? How far total does he swim? So this one is asking for a little bit more information, but I think that you should be able to do at least the first two questions. So let's go ahead and look at the setup. So I have a river. Here's my river. Okay, so this man is going north in the river of 2 meters per second, and he was going to also be pushed down the river because there's a current of 3 meters per second. So what we actually have is movement that looks like this. It is asking for how long does it take to cross the river, which is 100 meters wide. And then it's also asking for the distance that he swims down the river. So that's the displacement in the x direction, because down the river would be in the x direction, or east of in the river. And then it's also asking for the displacement, the total displacement though. So he really swam like this, so we need to know the distance that it takes to go this. So let's concentrate on these parts first. So the first thing I'm going to do, divide everything into x and everything into y. So in the x direction, my velocity is 3 meters per second. In my y direction, it is 2 meters per second. Then I also know that my delta y is 100 meters because he goes upstream or across the river, and that takes 100 meters, and that's in the north direction, so that goes with y. I'm looking for delta x. And then if I want to know the time in the x direction, remember that's the same as the y. I can't actually solve using x because I don't have delta x. So I want to know how long it takes to cross the river. So let's do that first. So remember, velocity is equal to displacement divided by time. So velocity is 2 meters per second here. Displacement is 100 meters divided by time. So let's get rid of time on the bottom. I don't like it on the bottom. So 2 times delta t is equal to 100. So now that I've done this, I can easily see I need to divide by 2. I only do this when the variable is at the bottom. So time is equal to 50 seconds. Since time is equal to 50 seconds here, it's also equal to 50 seconds on the x direction. So now let's go ahead and solve for the displacement in the x direction. So again, I'm just going to use my velocity equation. So I'm going to look at displacement in the x direction. So velocity is equal to 3. Displacement is unknown. And time is 50 seconds. So I need to multiply both sides by 50. So displacement is equal to 150 meters. Alright, so I still need to do one more thing in this problem. I need to find the displacement, the total displacement. And I cannot simply just add 100 to 150. That's not going to give me the correct answer. Because what he actually did is he went 100 meters to the north, and he also went to the east by 150 meters. So he actually swam this. So I can use this information to get me the total displacement. So my total displacement here, well, I've got two sides of a right triangle here. I can use Pythagorean Theorem. So a squared plus b squared is equal to c squared. So remember, c is the hypotenuse side. So x will be the hypotenuse side in this case. So it's 100 squared plus 150 squared equals c squared. So I get 32,500 when I do this is equal to c squared. So then I take the square root. So c is equal to about 180 meters, roughly. So he actually swam 180 meters. All right, so let's do one more problem. Okay, so an object is moving 50 meters per second at 40 degrees north of east. How far west does he go? And that should actually be east right here. How far east does he go after 2 seconds? East. Okay. All right, so let's look at the problem. So I have a man who's going 50 meters per second, or an object, and he's going at an angle that looks like this. And I believe the angle was, let's see, 40 degrees. Okay. I would like to know how far east, so that's displacement in the x direction, did he go after 2 seconds? So the time was 2 seconds. So in order to solve this, in order to get displacement, it would be nice if I had a velocity. But I cannot use this velocity because it's going at an angle. So what I need to do is divide into x and y components. So I need to get the velocity in the x direction. So if this is a velocity and I solve for x and y, the other sides of the triangle, I will get a velocity in the x direction and a velocity in the y direction. So I will need to get a velocity in the x direction first. So since I only have one side of the triangle and I have a degree or an angle, I can use SOHCAHTOA here. So when I'm looking at this, I'm going to decide what is my hypotenuse, opposite, and adjacent. So this is my hypotenuse because it's always not touching the right angle. This side, if I'm looking at this angle right here, will be my adjacent side. And then this side right here will be my opposite side because it's not touching this angle. So I'd like to use an equation that has adjacent and a hypotenuse in it. Adjacent because I'm solving it, and hypotenuse because that's the side I have. So if I look at cosine of theta, that's equal to the adjacent divided by the hypotenuse. So I have theta, I'm looking for the adjacent, which is Vx, and I have hypotenuse. So cosine of 40 is equal to the adjacent side divided by the hypotenuse side of 50. So cosine of 40 should give me, cosine of 40 will give me 0.766, which is equal to adjacent divided by 50. So to get this, I'm going to multiply both sides by 50. So the adjacent is equal to 50 times 0.766. My adjacent is equal to 38.3 meters per second. So my Vx is equal to 38.3 meters per second. Anytime that you are given a vector at an angle, you will have to take it apart into its x components and its y components. And then since I have velocity here, I will get a velocity when I solve for this side of the triangle. So now I can go back and I can solve for delta x. So my velocity is equal to 38.3. Delta x is unknown. Time is 2 seconds. That was given to me in the problem this time. So I can multiply both sides by 2. So delta x is equal to 76.6. So this person went east 76.6 meters. All right, you need to make sure that you actually practice this, which is why I gave you guys the practice sheets. Once you sit down and start practicing, you'll understand more of what you don't understand, and you'll know what questions are appropriate and what questions you need to have answered. But you cannot simply just watch the videos. You need to make sure you are doing some practice problems as well. So I will see you in class.